In this video, I'm going to explain the product of powers property, which occurs when we have two of the same base, but two different exponents, and how we can simplify that because we always want only one of each base. Let's take a look at our first example of a base of 2, then we'll take a look at a different base example of 3, and then we'll do a general base example of a. All right, first thing we have is we're going to use our definition of exponents to expand each one of these things to see how many 2's we end up with. All right, so 2 squared is 2 times itself. 2 times. All right, so then 2 to the third power, which is being multiplied by, is 3 2's, all being multiplied by themselves. And all we have to do is use our definition of exponents to be able to rewrite this. We need to count the number of 2's there. We see that there's 5. So now we know that 2 to the second times 2 to the third is 2 to the fifth. Should make a lot of sense. You're probably already thinking that this one here, well, that's tricky because there's no other exponent, but we should remember when there's no exponent stated like there is for this number right here, there's actually an imaginary 1 there. So we should be hypothesizing that it looks like we added the exponents over here to get to that 5. I bet that we're going to do the same thing, and I bet we're going to get 3 to the third power. But let's take a look. 3 squared is just 3 times 3. And we're multiplying that by, yup, there are 3 3's right there. So that's 3 to the third power, or 3 cubed. Now we'll take a look at the general case of a to the m power times a to the n power. And in a lot of examples, when people explain exponent properties, they use bases of a, and if a different base occurs, then we use a base of b. And for different exponents, we use m and n. Don't ask me why, I'm not entirely sure why. All right, so let's take a look. A to the m power is just a times itself m times. All right, easy enough. And then we need to then multiply that by a to the n power. All right, so that's a, again, times itself n times. And in math, this is kind of how we note those types of things, those triple multiplication signs there. All right, so if we had m a's here and n a's here, then our total would be the number of a's total. So that's m a's plus n a's, so m plus n. So it's exactly what we were hypothesizing from our 2 examples over there. And there is your power property exponent. Same base, different exponents, add them together.